Okay, so hello everyone. I am Pulkit Verma from Arizona State University, and I'm going to talk about JEDAI, a system for skill-aligned explainable robot planning. And this is a joint work with Shah, Trevor, and Siddharth Srivastava. And these are the people who have made contributions to this project at various points of the development. Yeah. And now moving on to the actual talk. So JEDAI is designed for outreach and educational efforts aimed at helping even non-AI experts to work with AI systems that can use symbolic planning. Now JEDAI features a simple drag and drop interface using which the users can create a plan to achieve a goal in one of the 5 robotic domains that we provide. And if the plan is successful, they can see the plan's execution on simulated robots. I will show a demonstration at the end of the presentation. But before that, let's see what specific problems we solve here. So JEDAI overcomes 3 technically significant challenges in making AI planning more accessible. The first challenge is the fact that inexperienced users will have no knowledge of the low-level constraints that real robots need to conform to. So we must somehow bridge this gap in expertise of these users because we cannot reason them to, we cannot expect them to reason like what each joint values of the robot will be. The second challenge follows from the first, and even if we can show users simple abstract representations of the robot's capabilities, that isn't much of a help unless we can efficiently convert back from high-level plans made of abstract actions to low-level motion plans that are suitable for a robot to execute. And finally, the third important challenge that we address here is helping users to understand a planning problem in a better way by computing personalized user-specific explanations automatically. Now let's see these subsystems that allow JEDAI to overcome these challenges. So JEDAI is built from a few key subcomponents that work together with the Blockly visual programming interface. Here you can see JEDAI's architecture. We'll now briefly go over each of these components in detail. So the first component is a task and motion planning system that handles the autonomous refinement of high-level plans provided by users down to low-level motion plans that the robot can execute. So this system takes each of the action in the high-level plan and tries to concretize it into a low-level motion plan. And for this, we use a system called ATM MDP that was developed by Shah et al. The next subcomponent is an algorithm for computing personalized explanations for plans that fail. So JEDAI asks users to put together action plans with visual blocks to solve the problems, but it can be hard for novice users to meet every necessary condition to create a correct plan on the first try. So when users submit a plan that will fail, then JEDAI displays an explanation that tells them what exactly went wrong with their plan. And for this, we use Helm that was developed by Srivastava et al. Now, finally, one of the barriers currently standing in the way of non-AI users who want to understand and interact with planning agents is the formality of the symbolism used by these agents. So JEDAI deals with this issue by using a third component that ties actions and predicates in a domain to snippets of natural language that can be combined into coherent sentences. And this allows states and actions to be expressed in a way that is less intimidating to users who don't have much exposure to concepts like predicate logic. Now let's see how JEDAI brings all these things together using a demonstration. Okay, yeah. So JEDAI users first need to pick a domain and a problem to work with. And here we give a set of 5 domains. And for each domain, we have an associated problem. And then we show the goal to the user that they have to achieve. It is also defined in English and showed as an image. And then there are some actions that the users can choose over here. And they just have to drag and drop to create a plan. for this demo, what I'm going to do is use a plan that we already created, because it takes time to create and refine it. Yeah. So now what happens if the plan fails? So in that case, here they can see, sorry about that. Yeah, so if a plan fails, it gives an error that, okay, the action at step 1 could not be performed because a particular plank was not held in the correct time. So these kind of error messages come, which are actually explanations of why this particular plan that the user submitted has failed. Yeah. Now, if we try to execute a plan that is correct, so for this, I'll again use a plan that we already created. So for a correct plan, this system tries to generate a motion plan first. And once the motion plan is correct, the users can see the simulated robot execute that particular plan in this simulator. Here, the Yumi robot is making a 3-story pie structure as given in the goal that we saw earlier. And this video is sped up 3 times because this actually takes time to execute the actual plan. And to help users getting started with this system, we provide a documentation and a video tutorial. And the code is also provided, and we also provide an already configured virtual machine for the users to use. Currently, the system comes with 5 predefined domains and a fixed set of problems to solve for each of those domains. And we plan to extend this set to more problems and domains. We also plan to improve the quality of the motion plans. As for now, like we currently use the standard motion planners that are available, and they might generate plans that are not intuitive to the user, right? So, for example, the hand is starting from a location A, and then it will make a weird rotation in the space to go to a point B, whereas it could have directly moved from A to B. So those kind of issues we have to fix. And finally, we plan to conduct a user study to evaluate this system at some point in the future. So with that, I would like to thank all of you for listening, and please visit our website to learn more about JEDAI. If you have any questions, you can ask now or contact me in the Slack channel. Thanks.
Thank you so much. Again, we don't have too much time for questions, but if anybody has any quick questions, yeah, I think then again, people can contact Pulkit on Slack.
Yeah, I have another quick question. Thank you very much for the talk, and great name, by the way. So, sorry, maybe I missed it in the talk. These things like is lying horizontally or is in left hand, you know, those parts, is in, is lying, etc. How are those generated? They already put in a priori, or is there something that you use to get semantic knowledge from the plans?
Yeah, so the domain is already there in the backend, right? And that is defined in terms of some predicates. We just show the interface in terms of natural language. So each of the block has these English representations of those predicates. So like
okay, so the English representations of the predicates are inputted.
Yeah.
Okay. All right. Great. Thank you.
Okay. Great. I think it's time to move on to the invited talk. I'll hand over to